Okay, we're looking at simplifying radicals. Okay, in this case, a radical is a number with a radical symbol. A radical expression is an expression, coefficient, or a variable with it. Okay, so 4 is my coefficient here. Technically, 4 is being multiplied by the square root of 10. Okay, that's my radical symbol. And 10 is the radicate. The radicate is the number inside the radical, or in the house. Okay, if we have a radical expression, here we have my index. This is being to the third root, which we have not talked about yet. Ours will all be squared, so there will be no number here. This is the radical symbol, and this is the radicate for x to the 6th. So we're going to talk about even doing it with the 6th. Okay, all of these, 1 through 10, we just did this for a warm-up, but we're going to do this again. We're going to do 1 times 1 is 1. That's a perfect square. The square root of 1 is 1. So you should be filling out this chart with me right now. This is just 2 times 2. 2 times 2 is 4. The square root of 4 is 2. It's important to have these perfect squares so you guys know how to simplify these things. 3 times 3 is 9. The square root of 9 is 3. 4 times 4 is 16. The square root of 16 is 4. 5 times 5 is 25. The square root of 25 is 5. 6 times 6 is what?
36.
What's the square root of 36 would be? 6. Notice how none of these have a square root over them. 7 times 7 is what?
49.
And the square root of 49 is 7. 8 times 8 is?
64.
And the square root of 64 is then 8. 9 times 9 is?
81.
And then the square root of 81 is 9. And 10 times 10 is? 100. And the square root of 100 is 10. Okay? If we're talking about x, x times x is x squared. And the square root of x squared is x. Okay? So, we're going to be talking about these. Perfect squares are the product of a number multiplied by itself. For example, 4 times 4 equals 16. 16 is a perfect square. Think about the process we just performed. Number, squared it, took a square root, same number. A root and an exponent are inverses for each other. They undo each other. Therefore, square rooting and squaring a number are inverses as they undo each other. Just like adding and subtracting undo each other. We've got some factor trees here below. Okay. A blank expression is in simplest form. A radical expression should be in the simplest form if no perfect square factors other than 1 are inside the radicate. No blank are under the radical. No x squareds. No radicals are in the denominator. You can't have ones in the denominator. Okay. Prime factorization is a number greater than 1 that has the factors of blank and blank. Is a number greater than 1 that has the factors of itself and 1. Okay? So we want to factor this as much as we can. So I'm going to zoom in on this. And we're going to do each of these. Okay. What two numbers multiply to give us 54 where 1 is a perfect square? So let's look at our perfect squares again. 10 doesn't go in there evenly, right? 9 and 6. And what's the square root of 9? 3 and 3, right? Okay, so we're going to do the same thing. We're going to do the same thing with 45. What two numbers multiply to give us 45? 9 and 5. Whose ever music is playing right now, please make it stop. Okay, what two numbers multiply to give us 9 again? 3 and 3. Good. What if you did like 3 and 15? What if you did like 3 and 15? Well, 15 is not a perfect square. That's why we wouldn't use it. because we want those perfect squares. Okay? Yes, those are factors that is totally reasonable to use, but we want some perfect squares here because we're going to talk about under the square root in a minute. Okay, what two numbers multiply to give us 98 where one is a perfect square?
12 times 8.
12 and 8, neither of those are perfect squares. So let's look back at our perfect squares. Okay, so we've got 98. We know 100 is not going to go into 98, right? Does 81 go into 98? Does 64 go into 98? 49 does go into 98. Okay, so 49 goes into 98 2 times. Okay, and what times what gives us 49? 7. So those are perfect squares. So we want to talk about that. Okay. 7 and 7, yeah. So 49 is a perfect square because it's 7 times 7. 36 is a perfect square because 6 times 6. Okay, so now we're looking at 108. We're looking at 108. We want to talk about what are a perfect square that goes into 108 evenly. So does 100 go into 108 evenly? What about 81? This is why you might want to have your calculator, because I literally have put those in. Does 64 go into 108?
No.
No. What about 49?
No.
Okay. What about 36?
No.
Yes. Okay. 36 and 3. I don't have any more, so I don't know where they are. People took multiples. Okay. What two numbers multiply to give us to get 36? 6 and 6, because it is a perfect square. Okay? So if I were going to do this, and I was going to take the square root of 108, I would then change it to the square root of 36 times 3. And then what is the square root of 36?
6.
So 6 now goes on the outside where the square root of 3 is in the inside.
Oh, we've done this before.
Yeah. We have. The square root of 36 is 6, right? So now that I've square rooted it, I bring it to the outside of the square root sign. The 3 stays there because it's not a perfect square. Yep. Okay, let's do some practice before I give you homework. Okay. And I will do a couple of your homework problems too. All right. What is the two numbers that multiply to give us 45 where one is a perfect square? 9 and 5. So we're going to go square root of 9 times 5. What is the square root of 9? 3. Square root 5. Okay. Now we're looking at 98. There is a negative on the outside, so we're just going to have to bring that negative down with us. What two numbers multiply to give us 98 where one is a perfect square?
49.
49. Good, because we did that one. What is the square root of 49? 7. So we're going to go negative 7 square root 2. Okay. All right, let's look at 48. Think about our perfect squares.
16.
So, 16 times 3, right? What is the square root of 16? So we get 4 square root 3. Okay. Now 4 gets a little strange because there's a number in front. Okay, for right now I want you to not worry about that number. What two numbers multiply to give us 45? 9 and 5. So we have, bring the 2 down, square root 9 times 5. What's the square root of 9? So we've got 2 times 3 times square root 5. And what's 2 times 3? 6. So we have 6 square root 5. Why don't you guys try number 5 right now? 5 and 6. None. Bye. Okay. So try 5 and 6 right now. Who needs help? Okay. So you get how we're just bringing this 2 down, just kind of ignoring it for right now, right? So 9 times 5 is 45. Square root of 9 is 3, so that moves to the outside. But then I've got this 2 out here, so I just multiply them together. And then I'm done. All right, I'm going to look at 5 and 6. You guys ready? Okay, so I need your attention up here again. And 5, 4, 3, 2, 1. Okay, so the square root of 20 gives us 4 times 5. Square root of 4 is 2. 2 square root 5 is my answer. Okay, 40, I've got that 4. I'm going to kind of ignore it in the front. What 2 numbers multiply to give me 40? But neither of them are perfect squares.
Whoa, what do you do?
4 times 10.
4 times 10. What's the square root of 4? So I go 4 times 2 in the front, square root 10. 4 times 2 is 8. Square root 10 is my answer. Okay. Should we keep going? Try a couple more? Okay. Number 7, I've got that negative in front, which I don't really have to worry about. I just have to keep it there. What 2 numbers multiply to give us 99 where 1 is a perfect square? 11 times 9. Right? Square root of 9 is, so negative 3 square root 11. You okay, Christian? Okay. What's your question, honey? For number 6, just bring it down. So I'm bringing it down but ignoring it. 40 is 4 times 10, right? Square root of 4 is 2, so I brought the 2 out, I brought the 4 down, and now I just multiply those together. That's it. So that 4, I brought it down, I brought it down again, and then I multiplied them together to give me 8.
Because the 4
Sure.
is saying 4 times the square root of 4.
See, when I did, I'm tripping. I'm breaking.
It's on the outside, so you can't do that. If it's on the outside of the square root, you just keep going. All right, we've done 8 a couple of times, so let's move to 9 real quick. What's the square root of 125? What 2 things multiply? 25 times 5. You guys, I need you to pay attention up here. I'm still recording this. I need you to be listening up here. Okay, what's the square root of 25? So 5 square root 5. Okay, we'll do 12. Let's do the 2 other ones first, though. What's the square root of 12? What 2 numbers? 6 and neither of those are perfect squares. 12 times 1 doesn't work. What else goes into 12? 4 and 3. What's the square root of 4? 2 square root 3. What 2 numbers multiply to give me 200 where 1's a perfect square? 100 times 2. Square root of 100 is? 10 square root 2. Okay, here's a hard one. Here's 14. Let's think about all the factors of 14. What makes up 14? 1 and 14 and 2 and 7, correct? That's it. Are any of those a perfect square?
No.
So that's it. Square root of 14. Can't do it.
4 times 3, 4,
No.
5. 3 times
Sure. We've done this one a couple times. It is 36 times 3. So it's 6 square root 3. It was in the example. Okay. Before I do anything else, I do want to do one of the problems from the back of your homework because it has X's in it. Okay, so it is different. So I am going to start with looking at number 14. Okay? So, first of all, the first thing I want you to do is ignore the X's. Everybody's got the back of their homework? Number 14.
I don't think everybody has the homework.
Oh, gosh. Okay.
It's okay, just write on the back of your note.
Who doesn't have it? Raise your hand. Don't say everyone. There's a bunch of people writing this down.
I feel like somebody took the Oreos.
Okay. So we're looking at number 14. And we've got 81. What's the square root of 81, guys? 9. Okay? So I've got 9, but I've got this x to the third in here. Okay, do you guys remember from your notes that we took? The square root of x squared is just x. Do you guys agree that x squared times x to the first gives me x to the third? When we are multiplying x's with exponents, we add them together. So we could take them apart in this way. So it's like finding pairs. Mr. Nowak explains it really well. He talks about if it's finding pairs of socks. So if I have 3 socks, only 2 of them can be a pair, right? And I'll have 1 left over. So I can take 1 pair out and leave my 1 left over in the inside. Okay? So the square root of x squared is x, right? Because x times x gives you x squared. So you know how I don't have an 81 anymore, right? Because 9 times 9 gives you 81. The square root of 81 is 9, so I bring on the outside. The square root of x squared is x. On the outside. Yes.
So you don't do 9x squared.
So it's 9x times the square root of x. I have like 4 people ask me a question at once, but I'm trying to. Yes, Nevaeh? So number 15. Nevaeh would like to do number 15. Okay. Because we got a lot going on. We got that 2 on the outside, which we still don't like. We need to find the square root of 84. And we've got x to the 4th. All right, so let's start with this. I'm just going to bring down that 2. I'm ignoring it. It's on the outside. What 2 numbers multiply to give us 84? Where 1 is a perfect square. 81's not going to go in there evenly. 64 is not. 49. 4 goes in there evenly. 4 times 21 gives me 84. Okay, what's the square root of 4? 2. So I'm going to bring that 2 down again. I'm going to times it by 2. How many pairs? I've got 4 socks in there, and I want to take out how many pairs there are. So there's 2. So we go x squared. And we leave that 21 on the inside. Now what's 2 times 2? So we have 4x squared square root 21. Okay, let's do another one where it's got those letters. You want to try 20? Okay, let's look at 20. What's the square root of 121? 11. Okay. It says u squared. So what's the square root of u squared? How many pairs do we have? 1. So we can take 1 out. But then we've got a v. But it's not squared, so it still has to stay under the square root sign because we don't have a pair. No single socks allowed to take out. You want to do 22? Yeah, that's it. Done. Okay, let's look at 22. Okay. What 2 numbers multiply to give us 50 where 1 is a perfect square? So let's look at our perfect squares again. 25. 25 times 2 gives me 50. So I'm going to take out the 25. The square root of 25 is 5. How many pairs of x's do I have? Do I have any? Nope, just one X, so I leave it inside. How many pairs of Y's do I have? I've got 4 socks, 4 Y socks, so I have 2 pairs, yes. Negative 3 times 5 is negative 15 Y squared, square root 2X. Right, it's the number of pairs, right? So I have 4 socks. I rolled them up, so I only took out 2 pairs of socks. So that's why the 2's on the outside. All the Y's moved out. They met up perfectly. Yep. This is the last one, though. Okay. What 2 numbers multiply together to give me 32? Where 1's a perfect square?
4.
What times 2 is 36? Is 32? What times 2 is 32? 16, and 16 is a perfect square. Okay, so we're going to bring down the negative 9. Square root 16 times 2, x to the third, y to the third. Okay, what's the square root of 16 again?
4.
So I get negative 9 times 4. How many pairs of x's do I have? So I get an x and a y. And what's left over? I still have this 2, right? And still 1 x and 1 y, right? And now what's 9 times 4? Yes. Negative 36 xy times 2xy times the square root of 2xy. We feeling any better about this? I know the x's threw some people off, putting the letters in there, but if you think of them as a pair of socks, I think that helps.
Well, what if it's just x and y? Would you
They're just, you just have one of each kind of sock. You can't take any out. No pairs. All right, I'm stopping.